this might only matter to about 50 people in the world, but if you care about networking inside data centers, then this video will be for you. Pluribus Networks is here showing us the latest and state-of-the-art software-defined networking for data centers. And I know a few people at Rackspace who will care a lot about this, but maybe not for everybody. Who are you?
My name is Sunit Tripathi. I'm the CTO and one of the founders at Pluribus Networks. I come from the world of servers. Before Pluribus, used to work for Sun Microsystem, and did a lot of the server and virtualization into Solaris kernel. And at that point, we kind of were looking to figure out the world what it is today. The entire racks working as one, network, server, storage, all combined together. So we set out to do that about 4 years back. So 2010 is when we kind of started doing this.
And who are you?
Hi, my name is Robert Drost. I'm also a co-founder with Sine of Pluribus Networks and currently also operating as a COO. And my background was also from Sun Microsystems. I worked there through my career, starting first in designing high-performance processors, and then moved up to doing high-performance I/O between chips, and then entire high-performance system design for HPC projects for the government and some other petaflop type level projects. And came onto Pluribus with Sine because we found that there was a great opportunity for doing something in the networking to improve the overall data center.
Yeah. So let's go up to 30,000 feet for the few people who are still listening to this who don't know anything about databases, about data center networks. What's the average data center network look like today? When you walk in, what do you see, and what's pushing all the data around, I guess?
So the average data center is still, the network in a data center is a very closed network, right? I mean, this is primarily where you'll see gear from people like Cisco's and Juniper's, and the goal of the data center was earlier pushing packets through with different protocols and stuff like that, basically. It's a very disconnected system from server and storage. You typically have a network which runs independently from servers and storage today.
So tell me, lay out the industry right now. We have some of the newer upstarts like Nicira that we've had in here before, and they got bought by VMware, I think. And compare what you're doing to the rest of the market, because most people don't know what what networking is inside a data center. They've never seen a Cisco box sitting on top of
that's a great question.
Machines.
That's a great question, because I think people have been hearing about the desire to make the network do more, to put things like SDN into it. And what's really unique about Pluribus is that we had the view that the network itself, the boxes that are in fact moving the packets, are a very good place to be doing network programmability and SDN and opening them up to all of the kind of programming and stuff that people have been used to for decades now on the server and networking side. That's sort of why you got a little chuckle when you said, are we competing with Nicira? Nicira is on the server side, and so people actually can do virtualization, whatever they want inside of the servers, but we felt like the network itself, inside of the network, deserved to have all of those cool new features.
So if I run a data center for, let's say, Walmart or Wynn Resorts or something like that, because I've seen their data centers are pretty well built out. Mm-hmm. They probably have a Jupyter box or a Cisco box sitting on top of 10,000 machines, right? That are running those 10,000 machines and shuttling data around, right?
Typically, it ends up being they have a box in the rack itself. It's called top of the rack switch. So you have a bunch of servers, 20 to 40 servers in a rack, maybe some storage, and you have a switch that connects all of them together, and it's the top of the rack switch. Then from top of the rack switch, you have a core network that connects all of this together. And the position where a lot of this is happening is in the rack, right? Because the rack is getting virtualized, rack is getting application aware, and the rack is being orchestrated as one unit, basically, right? So where earlier we used to deal with servers and storage and networking separate, OpenStack is a good example. OpenStack is trying to unify all of it, and it wants to make it run as one unit, which means the network really now needs to be similar to server and storage, right? So that's the kind of space where Nicira was also playing, and we are all trying to solve the same problem. It's like, in today's world, how do you make this all work together?
So what do I need from you guys? Do I need to take my Cisco box on top of each rack and put in a Pluribus network box? Tell me what I need to do in my data centers.
We make network boxes which are more like server, and these are called server switches. And you can use those basically, right? And these are all running on merchant silicon. There is no custom ASIC, and they're all open boxes. Or you can also use some of the boxes coming from Far East, the ODM boxes, what we call the new white boxes of switches, and put our OS on it. The work we have done is that we have integrated some of the systems together, right? So the hardware and software.
We might bring that slide up that you had.
Actually, exactly. Now would be a.
Yeah.
So if you look at this picture, the way servers used to be before, right? I'm showing the old style server versus traditional switch, right?
Yeah.
The old style server, if you notice, the CPU's memory are all controlled by the OS, and the NIC itself is sitting on the PCI bus and on the high memory bus, and it's trying to the OS is trying to control all of it together. The switching, on the other hand, was built around, if you look at it, low speed IO buses, right? They weren't meant for programmability, they were meant for human configuration.
Yeah.
What Pluribus is trying to do, our third partner is not here, Ken, basically, but between Ken, Robert, and me, what we have tried to do is just replace the NIC by a merchant silicon, both Intel and Broadcom, and keep the programming model and the box still like a server. So we have kept 90% of the server intact, including the operating system, and we just, instead of the NIC, bring a switch chip there. So this box at least looks like a server and behaves like a server, but at the back has 48 10 gig ports and 4 40 gig ports to connect the rest of the servers together.
And what does this mean when we go to this new model? What kinds of things happen to the data center? Does our performance get better? Do we get new capabilities?
It both enables higher performance for stuff that you'd be doing anyway, but it also enables a set of features that you just couldn't really get without this kind of tight integration between the server and the switch. One of them most notably is on the server side, that really is a standard server. This isn't sort of a server, a switch that they added an Intel processor. That doesn't already make it a server. If you wanted to actually run all the standard Linux tools out of the box with no change, right? If you want to be able to just put a CD-ROM, load it, and go on that, that actually is something that you need completely standard components. The other part is, by having so much bandwidth, you're able to do things on the control plane that otherwise would be impossible, like putting your control plane in the middle of every decision that would affect how the switch chip is moving data around. Other than the very simple hardware enforced packet comes in and it's just going out another port by layer 2 or layer 3 switching, you can actually go in and put C code in front of any of the other decisions that are going on in the network, and that's truly unique. In fact, when people talk about SDN, a lot of times they talk SDN, but underneath the SDN there's an incredible amount of stuff that's automatically happening in the network. In our environment, you actually have complete C, Java, Python, Perl, Puppet, Chef control over everything that's going on in the network.
So this makes it easier to maintain a data center? Or?
It's easier to maintain and program both. I think what Robert was trying to say and was mentioning the C and Java part, right? So the goal here is that your network, first of all, is very programmable, and you can use your standard tools like GCC, GDB to develop applications and program the network. And second of all, a new class of applications come up basically which weren't available before, right?
So like moving virtual machines around?
Moving virtual machines, tracking them from network point of view, understanding where they are moving, the life of a VM. Like Robert, for instance, you want to bring your infrastructure in. I mean, you are running a video here. You're literally a TV station, basically, right? Let's say, people are very interested in this. All of a sudden, 50 people, instead of 50 people, 5,000 people want to watch it continuously, right? And it's a HD video that's going to get delivered. So you want to reprovision your network along with your server and storage very quickly, and you are serving it out of virtual machine. So you want to change the entire infrastructure to say, hey, deal with this, right? I want all my resources to go towards serving these videos out, basically. And you want to do that with a click of a button or very simple stuff. And that's what we are trying to enable here, that you have programmatic control over the network. You already had that over server, right? So now the network is also under your control. So you can do end-to-end changing of application scale or rejigging your infrastructure to do what you are trying to set up to do.
Does this also let you build new kinds of networks? Like if I was at a pharma company, I might want to really have my data segmented because of HIPAA compliance or stuff
Absolutely.
like that?
You get an unprecedented level all the way down to layer 2 and how MAC addresses are handled and so forth. No communication sort of happens underneath you without you knowing about it. You know about any time somebody's trying to do something new, and you get a decision of should I allow it or should I not? Should I do a compliance? Should I do an audit trail on it?
What's the cost difference? Lay out the cost.
So,
because you know how pointing here
yeah.
bosses
You wanna take
decide
that
on
one?
things.
No,
They probably have a grid of performance
Yeah.
versus cost, and they decide on whether
Robert
to go
deals with a lot of the business side as well, basically. So instead of him saying the cost, I'm going to tell you, this is the merchant silicon-based stuff. This is the similar price points as servers, basically, right? And this is one big driving focus of all this industry is that, how do you move the value from the underlying hardware to actually more software, basically, right? So one of the big things we are trying to achieve here is that, the world of networking today is built on cables and physical hardware. And we are trying to make it so simple and programmable where instead of just dealing with cables and physical hardware, you're now dealing with operating systems and applications that help you achieve what you want. And it's all at the server scale, server pricing, and server application pricing points, basically.
Yeah.
So in other words, we are very, very reasonable.
Yeah.
Yeah, I mean, just, I think a lot of when Sune's saying that stuff is a lot of things in the networking world are built around 60 to, with cables transceivers, 90+% margins. The server world where we've come from and where we feel like networking is going to operates at 15 to 25% margins. And those sound like small differences in terms of percentage, but when you actually look at it, that causes the price difference to be 4x in terms of the actual street price. So we're operating at that low price point on the hardware side with the extra value on the software side.
Right. Yep. And we have built our own server switch, which lets you do unique stuff, and obviously we charge some margin for that, basically. But if we are running on ODM boxes that are coming from Forest, we are not trying to add money on top of that, basically, right?
Yeah.
So we are supporting there, and we are just adding software and so on and so forth for top to make it run like a traditional network.
Here's where I'm at a disadvantage to like a CTO who really knows what they're talking about.
Yeah.
Because I know the industry at an inch level deep.
Yeah.
What is the guys at Amazon or the guys at Microsoft or the guys at Google or our Rackspace data center buyers? How are they going to decide between?
So actually, I'll take this one because this is actually more of a software question. Because when you talk with Amazon and Rackspace and some of the big guys, the hardware goes out of the equation because a lot of them just say, "I'm going to get my hardware myself," right? So it really becomes a software question. And there, I would say the 30,000-foot level is, we believe our operating system, which is NetVisor OS, which is a shortened version of a network hypervisor operating system. It's an OS that runs distributed across all of your switches that are running it inside of your data center. That OS is hands down the best networking OS in the industry. That's a statement that we feel like we can defend, no question, on the technical side.
See, the reason Robert said that is because
he wouldn't say it that strongly. It's a funny thing. Sune's background is software. My background is hardware. We affinity for each other because I have true respect for great software, and he loves great hardware.
Yeah.
Yeah,
because that stuff runs faster on great hardware.
That's exactly, you said it, right?
I put my money where my mouth is. When I did my PhD in electrical engineering, I also did a PhD minor in CS just because of how much I respected computer science. Anyway, I'm kind of a closet programmer.
Yeah. What would be the kinds of questions that a CTO would ask you guys to try to differentiate and decide on whether they're going to go on with you? Because this is a big investment, right? These data centers now are
right.
So
like
Robert,
we have even Rackspace, which is not the biggest, has hundreds of thousands of servers now.
You asked a very, very loaded question, basically, right? And you presuppose that with the big deployment as well. And I just want to start with saying that it's not just Amazons and Googles and Rackspace which are looking at this trend, right? We are seeing this trend in the enterprises, we are seeing this trend in the ISPs, we are seeing this trend in the service provider, and we are engaged with all of those basically, right? So the interesting part is the question comes in differently based on who they are, right? Some of the bigger players, because they are so involved in the saving the actual hardware cost, our discussions are totally built around the software basically, right? They negotiate the pricing for the hardware, we provide the operating system for their hardware they negotiate. And the discussion with us is how do you make that hardware run more efficiently? It's same as you buy your server from Supermicro basically, and then you're gonna get your Linux, and you focus on value with Linux, and you're talking to the Linux guy separately from the Supermicro guy. So similar model basically, right? But in the enterprise space and in some of the service provider space, these guys use the network to get advantage, because their goal is, unless the application works better, they're not going to make money basically, right? So they are looking at network as a differentiator. They are looking at network as something that will add value to their application and simplify their operating model basically.
You had a demo or something, I think?
I was just setting up for that.
Yeah.
So should we bring it on?
Yeah, please do.
Let me have one over there.
What are you going to show us?
Let me show you. So I'm going to jump into our dev network basically, that is in Palo Alto, and we're going to get live into some of our switches that run our entire infrastructure.
Okay.
One thing we ensured from early days, for 2 years now, we have been running totally on our own gear, right? Our entire office runs on our own gear, and this is how we've been successful in our beta program, where people are paying for our beta basically, right?
Dog food it, right?
Yep, yes. So I'm logged into what looks like a server, right? I mean, you can actually see typical, it's a dual socket machine with multiple cores and so on and so forth. You can run top, and you can see this is a 64 gig machine with all the processes and all. But the interesting part is this is really a switch basically, right? Anytime you want, you type CLI and you're into the switch side basically. You can start doing something very simple, a port show, and you can see every port that exists on the network, right? So Aquila 12 is name of the switch. Port 9, you can see what is the IP address. Port 9, another IP address. So it looks like there's a server connected on that port running a bunch of VMs, right? You see those VMs right here itself, right? So let me reduce the font a little bit so I can fit all this in one line. Okay, much better.
Perfect.
Right? And you can see that basically what VLAN it is on, what VXLAN it is on, whether it's a host or not, all that is visible right here. You can actually go down, you can see Aquila 12 is connected to Aquila 2. It's a auto trans. So remember I said that we are trying to simplify all the cabling and all.
Yeah.
In our world, you just need more bandwidth between two switches, walk over, find two empty ports, plug a cable, walk away. Nothing to do, even if trunking, pathing, all that is automatic here, right? Yeah. If you keep going down, you will see the other switches in the fabric. So one of the things we are trying to support is the network as one logical network, right? Get away from virtual and physical network being separate entity, right? So you can treat your entire stuff as one logical network, and that's what you start seeing here, right?
If we have mixtures of Cisco boxes and then some of your boxes, can we still get some
that
of
That is an excellent question. You said you're not like a CTO, but now you're talking like a total CTO. So that's a very deep question, Robert, because we actually do get a lot of questions around there basically, right? So our protocols are very open protocols. We use standard TCP/IP to talk to each other. We use server-style clustering to connect to each other. So reality is you can have Cisco switches in the core, and we actually recommend leaving the core network alone, and we just work through the core network without any issue, right? I wanted to show you one more thing since we are on the demo basically.
Actually, before you hit return on that, one thing that's useful to point out here is you see status of these machines over here. Yeah. All this information, LLDP, DHCP, so forth, this is information that we know about the machines that are connected to the network without putting agents on them. And the reason this is such a powerful place to be in the network seeing the traffic go by is because we see the machines going out there in order to get services and so forth, so we can actually determine what's happening inside of a server essentially without going inside of it. It makes us very open and compatible to whatever OpenStack or CloudStack or VMware or whatever you're running, or even physical machines that you're running on the other side.
This helps you debug what
Yeah.
problems that are
Total
going on.
visibility.
Total visibility. This is exactly what another application we are showing on our own OS. It's analytics and logging, basically, right? So
Does this help build a more secure network?
it
Yes.
builds a more secure network, builds a more programmable
Because
network.
if somebody was trying to attack your network, would you be able to see more data about the
Yes.
network? with
Totally,
your stuff?
totally.
Yes.
Every connection is visible. So let me walk you through a live example, right? So you see we are seeing these client talking to these server, what is the service, what is the average latency they are seeing is right here, how many bytes are going through. This was 0 second away, this is real time. You keep going, you can see the older data right here. Basically this is 9 second, 11 second. And we go back in time, right? So a lot of it is historical data is there. We keep it memory mapped. We put it in our Fusion IO disk for analysis.
And this is why your box has, 100 gig? How many gigs of
So the
memory?
boxes, they can go from as low as, we have boxes that do 8 or 16 gigs of memory, and then we have available options. If you care about the analytics and want really deep inspection of everything, then you just bump it up to 64, 128 gigs. We can even go up to 512 and a terabyte on one of the boxes.
Very cool.
Right, so to go walk through the example that you're talking about, all I did was I said connection show within last 20 seconds, right? I want to see everything in the network within last 20 seconds. And we are seeing a lot of these things like 10.9.10.200 talking to this something with a higher average latency, right? Now I can tell you just looking at the IP address, this is a client talking to something outside. But if you want to see what else is it doing, so you just do this, you say connection show.
And you notice the CLI is very easy. You just hit tab, you get to the next word, the next word.
So
It's a RESTful CLI. You just type a command, Unix style. Whatever you're going to type, you type one command. You're not in a mode. It executes. It gives you the information back. That's why it's a fundamentally scriptable API.
So we turned it around. Now we are looking at this client, which all server does it talk to? And we can go down and we are now seeing what are the servers this guy talked to, right? You can actually pick in one of the servers and say, okay, why is this guy talking to this server so much? So you can just say connection show, right? And say server IP, and I'm just gonna put the server here, right?
Yeah.
And then immediately you see who else talks to this guy. Looks like this particular client talks a lot to this particular server, basically, right?
Yeah.
But you're seeing their average latency, you're seeing all this stuff. And where this is coming from is our flow capability, right? SDN is about flows.
What does that mean, flow?
So flow is anything how you identify a set of packets on the network, right? So somehow, I can tie a flow saying Robert's packet on the network is a flow, right?
Mm-hmm.
And I'm not going into the virtual network side of the thing, but you can create a virtual network here and say anything belonging to Robert is a flow, which is Robert's flow,
Got it.
right? So it doesn't matter what client, what server, what IP, based on VLAN, based on VXLAN, based on service you run, we can create a flow out of you.
So
But
you can see if I do, let's say we're building this for Facebook.
Yeah.
When I do a Facebook request,
Yep,
that data
totally.
goes from, comes from 100,000 different
Totally.
servers, and you
That's
can
right.
see
where
what-
it's going,
yeah.
where it's as it jumps to the network.
It's like a distributed version of Wireshark
Yeah.
in a sense. Wireshark would be on a single machine, but the idea here is that the flow is passing through potentially dozens of hardware boxes, and it may be layer 2, it may be layer 3, it may go into tunnels for VXLAN and so forth. And the point is being able to identify the flow no matter where it is as it passes through the network.
But the part I was also
If
gonna,
somebody added 20 new machines to your network today,
you'll see it immediately.
Yeah,
you'll see
You'll
it.
get a call back. In fact, what you can do is, I'm going to quit out of the CLI, and I'm going into scripting mode. The same command we were typing through CLI. I'm just going to type it here, and it immediately returns you all the data, basically, right? So you want to start doing scripting. Choose your shell. You can say while one, right? We were talking about monitoring. We just say this and sleep every 5 seconds, and you say end, and every 5 seconds this is now gonna keep repeating, basically, right? So notice how easily I transition between programming, scripting level programming, into CLI and so on and so forth. Switching into C and Java is equally simple because what we keep is our data structures and command and arguments all consistent. We are fully multi-threaded when it comes to programming the switch.
Yep.
So you can actually switch between any mode that you want, basically. And to your example, you can easily monitor what's going on and put it in your own files, log files, and monitor it and see what is different.
No, that's cool.
But
how long does it take to learn this new world compared to if you were running a Cisco switch today? How long does it take to learn?
That is a very excellent part.
All
right?
the stuff that you can do.
So we bought a lot of stuff very similar to from the server side, basically, right? So people who are familiar with doing stuff on the server side, orchestration side, this just makes so simple for them. But by putting a CLI there, which actually lets you deal with ports, like very simple configuring VLAN across the fabric. You can see every VLAN here. We don't have VXLAN configured here. Let me see if we have any.
Now you guys are a new company. Do you have customers at a big scale using this yet, or because you probably need the social proof to prove that the stuff actually works at a.
Yeah, we have customers. What we found is that customers try out kind of a pair of boxes, 2 to 4 boxes. And then after that, the next step is they want to get into pods that are 10, 20, and the step after that is in the hundreds. And we've taken customers up that ramp at this point.
Yeah.
I think a really important point for the people who are used to being on the NetOps side is that fundamentally, even though we show a lot of stuff that's programmability, other advanced capability, the first thing you do with the box is you can just replace your non-intelligent layer 2, layer 3 switch and just run the commands to set it up, very similar to what you're used to right now. And in a sense, you can then take the baby steps of now the box has the extra capability, learn it and use it. The first time you have a problem, go in and learn about the debugging, start putting the flows, tap, see what happened in your network. And what you find is you have Gigamon type capability, software defined, just all over your network right away.
That's cool.
Yeah.
Tell me a little bit about your company. How was it funded, and how many people are working there?
So we started about 4 years ago now, and we've done 3 rounds of financing. Total of about $45 million has been raised. And like Sune was saying, we're doing a launch tomorrow, but we've been in a couple dozen customers for the last 2 years doing betas and kind of stealth mode, going into production with them and so forth. We're a well-sized company at this point. We have a good number of software engineers, some hardware. We have relationships with a couple ODMs already over in Asia, so we're good to go.
Very cool. Where do I learn more about it?
Pluribusnetworks.com. You'll go there, you'll see everything. Tomorrow we are launching, so you'll see a lot more details.
Yeah, it'll happen in the past.
It'll happen in the past.
Yes.
You will have seen that we launched already.
Yeah.
Very cool.
Yeah.
Well, cool. This is good stuff, and thanks for what you're doing for the cloud and network, the data center worlds. Right.
Hey, totally appreciate that, Robert. It's people like you who help promote this new world of technologies.
Thank you very much.
Thank you.
Thank you.
Great.